So I had a real bad day, and I think I had a real bad day yesterday, and the day before, and the day before. And I think I'm going to make a video just to make myself feel better. This is granite from the Sierra Estrella here where I live, and some of it's got blue stuff in it, and you can see the blue stuff. Granite is supposedly mostly quartz and feldspar. Okay, and these are supposed to be separate crystals in there, and I don't think they are actually. Lots of the blue stuff here, and you see the shape of this. It's actually a tetrahedron, which is a four-sided geometric figure. 1, 2, 3, 4 triangles. Okay, and that is part of the cubic system. And what we have here is some dirt. And the black stuff there, watch the black stuff. You know, this is a good one. This one. See how it goes all silvery like that? In the books, it tells you that the stuff is mica, right? Mica's like really soft and sectile, which means you can like peel it up with your fingernail and stuff. And this stuff isn't soft or sectile. It's got layers, but it's not. It doesn't come apart real easy. And actually, what that is PT 190 platinum 190, and it's the radioactive isotope of platinum. And it gives off both alpha and beta emissions. And the blue stuff is kind of associated with that. This is not, I think, turquoise. It might be. Might be, but there isn't any copper in there. See, there's some gold. That's what the gold-colored stuff is. There's really only one gold-colored metal in the periodic table, and if you look here real close, you can see that there's a kind of a pattern. See how they're dished in there? That's called a hopper. And cubic metals like platinum and palladium in particular have hoppers. And that's what makes them really, really good. And here's one. There's a really good hopper on this side. And you can see the little black spot turning silver in there. And it's black. PT 190 does not have quite enough neutrons for stability. And that's why it's radioactive. Okay, and so because it doesn't have enough neutrons, it's trying to absorb neutrons, which is why it's black. But it's still platinum, which is why it's shiny like that, silvery and shiny, because platinum is actually a white metal. And what you're seeing here, there's kind of a white and a gray metal. The gray metal is platinum, and the white metal is actually palladium. Um, and they form a cubic crystal together in cubic unit cells that are, in this one, shaped pretty much just like this is. Unit cells are the smallest unit of the crystal structure. Okay? And in here, there's unit cells, and see, there's another hopper, and they kind of form right under the apex. Um, it's another one. So anyway, these hoppers are where all the catalytic magic happens with platinum and palladium. Um, and instead of being 7 on the Mohs scale of hardness, like quartz would be, it's actually 10. It's very, very, very hard and really, really, really heavy. And some of it will actually stick to a magnet because it's diamagnetic, which means it kind of sticks and kind of doesn't. And it falls off real easy and stuff. But there you can see the kind of cubic structure and the shininess there. And this is yard gravel from my backyard. Far out, huh? Hey, man. But this platinum and palladium is locked up in this crystal structure with covalent bonds. The platinum is bonded to platinum in covalent bonds, and the palladium is bonded to palladium in covalent bonds, and there's some gold binding it together. But in the planes of cleavage, you can see here real clearly, going in two directions, three actually. Um, this, this, and one over here, and they kind of join like at I don't know, 15-degree angle there or something. Part of the 30-degree angle, 60-degree angle of actually a hexagon, because hexagonal and cubic are related to each other, because of the way that rows and columns of things that are all the same size occur, the stacking order. So there it is. Platinum and palladium, radioactive, from my backyard. My backyard is so radioactive, I can't grow crabgrass. But I get these beautiful little blue hearts out of there. Far out, man.